Alright, so today we're going to be doing 5.0, which is going to be antiderivatives. So yesterday, if you had any struggles or confusion, we're going to address that. But you're going to see how doing what you did yesterday will help you basically get a leg up in this lesson, okay?
Yeah, I was so confused.
Alright.
I was tripping.
So, did I accidentally save over it without writing on it? Oh no.
Oh no. Gosh darn it, Miss Russell. Gosh darn it.
Just
That's not the answers. There's no way.
I mean, yeah, but I just want to go through and show you guys. So.
Yeah.
It's not like a secret. I just.
Oh wait, that's. I thought we were looking for the antiderivative of each of those. Okay.
No. Let me go ahead and erase these real quick.
Every answer is x squared.
You guys should know why, right?
Because the constant goes away. Oh,
yeah.
The -2 and the 1 goes away. I don't understand how that goes. How does 1/3 x3 go to x2? To be honest, I hate it. Doesn't make any sense. There's this kid in 5th period, and he just constantly says it. Oh, that's a no one.
Oh, how is it almost April? How? We're almost done. We're almost through it. What we get out, May 9th?
Alright, now we're ready. So, let's talk about it. So, antiderivatives.
I know what the first one is.
Step 1, let's go ahead and talk about how we find antiderivatives, all that stuff, and the purpose of what we're going to be talking about today. So, how to find the antiderivative? Well, we're going to talk about just finding the regular derivative right now. So, of course, we find the regular derivative, the exponent goes down, and whatever it goes down, whatever the original exponent is what we're going to multiply out front. So, what would be the derivative of 1/3 x cubed?
I don't know, man.
X squared. And then what's going to be the derivative of this one?
X squared.
But different.
And this one?
X squared.
So the whole goal to understand here is that several different functions, there's actually infinitely many functions that have the same derivative, okay? Which means that we need more information in order to be able to figure out what the function is just based on the derivative. So we use something called c to indicate the constant that we don't know what it is, okay? But there are ways to find the constant, and we'll talk about that in the next step. All right, so here's some important information. If you are given the function as a derivative, okay, and then you're finding the antiderivative is going to be just the regular function, okay? And when it is, you're going to put plus c there at the end of it, okay? This one here. If the function is given to you and you're asked to find the antiderivative, see how this one's just given to you as the regular function? You're going to call the antiderivative by capital F if it's given to you that way, okay? Because you always have to be going backwards a step, okay? But of course, you're going to put in the plus c. All right.
If we do like -5 or something, right?
Yeah, don't do that. All right, so let's talk about it. Let's say we're taking the the antiderivative of c. So remember, there's already an implied x to the 0 power next to it, correct? We know that when we take the antiderivative, the power goes up 1, and whatever it goes up by is what we divide the constant by, correct? So this is just going to be cx, correct? Plus c, of course. Okay.
Wait, why is there implied x then?
Just to help you understand like why it becomes cx. So like, what's the antiderivative of 2? 2x plus c, right? Because what's the derivative of 2x? 2. You see how you're going backwards?
Okay, yeah, okay.
All right, so this one here, before we get into x to the n, let's talk about x cubed. Okay, let's just talk about x cubed. What would be the antiderivative of x cubed? So,
No.
1/4 x to the 4th. So power goes up by 1. You divide by whatever that power goes up by. Okay? So if we're taking something more arbitrary, like the derivative of x to the n, we're going to have to do what to the exponent?
+1, and then it's divided by n plus 1.
Correct. So you can either write it as 1 over n plus 1 times that, or you can write it over n plus 1. Same thing. Same thing. Yep. So that's the idea, okay? Now 1 over x we could rewrite as x to the negative 1, correct? What happens if you add 1 to negative 1?
It becomes 0.
0. And then normally we divide by what that new exponent is. Can you divide by 0 in math? So this one's an exception to the rule, okay? Anytime it's negative 1, it's just ln of x. And you're going to see often they will put absolute values around this, just like a little rule. We'll talk more about that in the future. I don't want to get into it too much. And then, of course, plus c. Don't forget your plus c's. I will forget them sometimes, so remind me. And that's because what is the derivative of ln of x? You guys remember that one?
1 over something.
1 over x. So it's just working backwards from the derivative, correct?
Yeah.
All right, what is the derivative of e to the x?
E to the x.
So what do you think the antiderivative of e to the x is?
E to the x plus c.
E to the x plus c, very good. E to the x doesn't change when we differentiate it, antiderive it, all that good stuff. Okay, what is the derivative of sine?
Cosine.
So if we take the antiderivative of cosine, it is sine. This one's where it's a little bit more tricky. What is the derivative of cosine?
Negative sine.
Good, but that's not what we want. We want regular sine. So how can I counteract that?
Negative cosine.
Negative cosine. And you can think about it because what is the derivative of cosine?
Negative sine.
What's a negative times a negative?
Positive.
You see how it works? All right. What is the derivative of tan?
Secant squared.
So the antiderivative of secant squared is tan. This is one you probably don't remember from your yellow sheet.
That's cosine.
Is that
Secant.
secant squared?
Secant.
I was about to say it. I was like,
The derivative of secant is secant times tan. So, of course, the antiderivative of secant times tan is secant.
Plus c.
Plus c, very good. Anybody remember these ones?
The top one's sine.
Sine, inverse, right? Not just regular, but inverse. Remember the inverse ones? What is the middle one, or the bottom? Tan. That's the one you're going to see come up the most. And then the last one, you remember?
Cosine. No. That.
No.
No, it's
Secant.
Because it's x. Yeah.
So here's the way to remember that. You guys, there's a lot of like talking and distractions going on. Like if we cannot do that right now, because it makes it 10 times harder to teach something difficult when I have to like do it while I'm trying to be pulled away from something. So we cannot do that. How you can remember this is all of the c ones, the cosine, the cosecant, and cotan are the negative ones. So any of the positive ones are going to be the ones that are not c. Okay. All right.
Will we ever have to use cosecant stuff?
You will use it. Keep in mind, the one I would really give you on a quiz, most likely, is tan inverse. Okay. If I give you anything else, I would tell you ahead of time. All right. So here's the most important thing that I need you guys to understand. I'm not going to give you a antiderivative to solve that I haven't taught you the procedures on how to solve. So if it looks like something you don't know how to do, you just need to rearrange it. Okay, does everybody understand that?
Yeah.
So here, I'm going to just rearrange it. I haven't taken any antiderivatives yet. I'm just working on rearranging. Okay? So notice here, I'm dividing each of these numerator pieces by x. So what would be x to the 5th divided by x? X to the 4th. And then this piece right here, yes, exactly. This piece right here is a little bit different because I have to rewrite the square root as 1/2, correct? So it's like x to the 1/2 over x. Remember, you subtract. So what's 1/2 minus 1? Negative 1/2. Now we're in a position where we can take the antiderivative, right? So when you go to take the antiderivative, if it's given to you in the format of a derivative, remember, you're finding the function now. So you don't need to put the prime there anymore.
Does it have to be a capital G?
That's only when the original one given to you is not the derivative, it's just regular. That's when you go capital. Okay?
Okay.
So, what it...
Okay, we were given the derivative.
Exactly.
Oh, yeah.
What would be the derivative of, the antiderivative of sine? Negative cosine. This one here is going to go up a power. So it's going to go up to be the fifth, and meaning we're also going to be dividing by 5. Remember, when you're doing anti, you're adding. So what's 1 plus negative 1/2? 1/2. So this is going to be to the 1/2 power, but remember, you have to divide by what your power is, correct? Your new power. So when you divide by 1/2, it's the same thing as what? Multiplying by 2. And then, of course, don't forget the plus c. For that constant, we don't know.
Jesus fuck. Sorry. Stop recording. Sorry to your YouTube fans.
All right, anyways.
It's rated E for everyone.
Yeah, it was until now. Okay.
PG-13.
So this one here, we're going to have to rewrite this in a way that we know how to solve it. Remember, there's always going to be a way to rewrite it in a way that follows one of the things on the chart. So I'm not taking any antiderivatives yet. I'm just rewriting it. Anything negative I can put to the bottom to make positive, right? So you want to, sometimes you're going to rearrange it a few different times until you get it the right way that's needed, okay? So for this one here, does this one look familiar to you at all right here?
This looks like a tangent.
Tan inverse, right?
Tan inverse, yeah.
So this is going to be f prime of x, I'm sorry, f of x is equal to what?
E of x.
E of x.
Plus
20 times tan inverse of x, right? Plus what? Now here's where things are a little bit different. Notice that we have to find c. So because of that, we're given a condition about the function. So this condition, this is just function notation, and it just tells me that this function has a point 0, negative 2. So what can I do with that information, you think? Plug it in. So remember, f of x is just y. And then I'm plugging in for 0 for x. So is everybody good with what I did there? So this becomes 1 plus 20 times 0. Tan inverse of 0 is 0. You can do that on the calculator. Plus c. This becomes 0, so we end up with this. And then subtract on both sides, so you get c equals what? Negative 3.
What?
So, often the question is not going to ask for c. They're going to want to know the original function. So what you're going to do is you're going to go back and rewrite the function. But instead of c, you're going to put in the constant you just found. So you remember how earlier we talked about how we can't find the whole function based on just the derivative? This piece of information allowed us to find that missing information.
So is that the only way we can be able to find it?
You'd have to be given.
What?
Yeah, I would have to give you some type of information about it. There's varying types of information I could give you. Like there's more complex stuff you do in higher math, but like there has to be a piece of information. There's no way to do it without.
Okay.
Okay. So what do you notice about this question?
Oh, it's double.
It's a double derivative. So in order to find the function, we're not going to have to just antiderive once. We're going to have to antiderive twice. So the first one, when it's a constant, it's going to become what? 4x minus 3x squared, right? Minus 10x to the 4th plus c. Does everybody understand how I got that?
Yes.
Now when you introduce another antiderivative, you're not going to just have c, you're going to also have d as a constant as well. Okay? So the next one, we're going to do it again. This is going to become 2x squared minus x cubed minus 2x to the 5th plus constant becomes cx, correct?
Yes.
And then plus d, our new constant. So this is what we have so far. okay? Now we need to use the information given to us. So they're either going to give us 2 points on the regular function, or they might give you 1 on the derivative, 1 on the regular function. So let's go ahead and work with the one with the derivative first. So we're going to plug this into the derivative because see how it says prime here? That tells me it goes into the derivative. So with my derivative function, it's going to be 1 equals, and then I'm just plugging in 0 for all my x's. Does everybody see why I'm doing that? So that means c equals what?
2.
No.
What?
1.
Where are you getting what?
The old castle out.
I look at 2.
Oh, you were looking at the function 1 by accident. So everybody see how I got c to be 1.
Yes.
Now, when we go to plug into the new function, I'm not only going to plug in 2 for f of x and 0 for x, I'm also going to plug in what? 1 for c. Did I plug in everything okay? Oh, I plugged into the derivative, that's why. Or no, I did or did I not? No, I plugged into the function, didn't I? I did it right? Okay. So d equals what?
2.
So then what you would go back and do is you would just replace these values in the function here with what they are. So that would be your actual function. Okay? So any questions about that? How I found C and D? You got it? Okay. All right. So the next one's a little bit different because they didn't give me any values for my derivative. They only gave me 2 values of my function. So a little bit of a tip. If it's a second derivative, they're going to have to give you 2 sets of information to find the missing constants, right? Because there's technically 2 constants that are coming about. It may be 1 derivative, or it could be 1 derivative and 1 function, or it could be 2 about the function. So step 1 is we're going to find the first derivative, which is going to be 4x cubed plus 3x squared minus 4x plus c. That look good? And then the regular function is going to be x fourth plus x cubed minus 2x squared plus cx plus d. Does that look right?
Yes.
Okay. Now we're going to plug each of these in separately. So you can plug in either one first. I'm going to start with this one. So I'm going to plug that in. So you're probably going to start seeing a lot of the ones with 0. Like you notice that most of the things just go away. So here we get d equals what? 4. Now that we know what d is, I can now plug all of this in with d as well, right? So this is 1 equals 1 plus 1 minus 2 plus c minus 4, or plus 4. These go away, and it becomes 1 equals c plus 4, which means c equals what? Negative 3. So then your final answer, you would just rewrite the function, but you have to put in c and d. If you guys like this procedure, there's a whole class dedicated to doing these with like hundreds of constants. It's called differential equations.
It's not too bad.
No. Yeah, pretty